Hi, I am Dr. Sumitra, Assistant Professor of EC Department, SRMIST Katangulathur Campus. In the subject Analog and Linear Electronic Circuits, today we discuss amplifiers and particularly the introduction of feedback amplifiers. So in the amplifier design, we can give either negative or positive feedback. But when we apply negative feedback, it used to improve the properties of the circuit. For example, gain. The stability of the gain can be improved. Without feedback, the circuit will respond to temperature variations, transistor component variations. But with feedback, we can able to control the circuit operation to rely only on the feedback components so that we can able to design more reliable circuits. Reduces nonlinear distortions. So nonlinearity can be reduced that occurs mainly due to non-ideal characteristics of the components used. So linearization can be maintained by applying the negative feedback. And the noise. So without feedback, when we apply the input signal, the signal gets boosted along with the noise. But with feedback, we can able to reduce the noise component being boosted along with your input signal, and we can able to control input and output impedance. For example, if you are using voltage series, input impedance gets increased. Voltage shunt, output impedance gets increased. And extension of the bandwidth, in the sense wider frequency response can be obtained once when we apply with feedback. By comparing with without feedback, the frequency response is higher so that we can able to apply for high RF. Let me look into the general feedback structure, which contains an amplifier. The part of the output signal gets feedback. That part fraction is called as beta. And we have a mixer circuit which produces the difference between the two signals, XS and XF. So when we look into the equation, X0, output equation X0 is equal to A into input signal Xi. X0 is A into Xi. And when we consider XF, it is nothing but a signal with feedback will be equivalent to beta into X0. And Xi, as I said, this is a mixer circuit which provides the difference between the two signals, XS minus XF. So once when we design the gain will be equal to output by input. But gain with feedback will be equal to X0 by XS, where XS is equal to Xi plus XF. Divide both numerator denominator by Xi, will get AF, that is amplifier with feedback, is equal to A divided by 1 plus A beta, where that A beta has got loop gain. So from this equation we can tell that the gain with feedback component will be smaller than the open gain component by the quantity of 1 plus A beta, which is called the amount. So the amplifiers, that is general amplifiers, not feedback amplifiers. General amplifiers gets categorized as voltage amplifier, current amplifier, transconductance, and transresistance. Once when we thorough with all these amplifier structure, it is easy to understand the feedback amplifiers, right? So this amplifier is categorized mostly on the based on magnitude of input and output impedance with respect to load impedance. Let me get into voltage amplifier circuit. On seeing the circuit itself, you can see input voltage, input signal is your voltage, and output is also the voltage. So V0 is equal to AV into VI, which is voltage controlled voltage source. So it is an voltage amplifier. V0 is equal to AV into VI. In the circuit, input impedance will be very high, output impedance will be very low. So we can say input impedance is infinity or is 0. Next, current amplifier. Current amplifier is an amplifier which provides an output current proportional to the input signal current. So it is a current amplifier. In the circuit also you can see here I0 is equal to AI into IA. That is nothing but output and input gets amplified by the factor of AI. So in this case input resistance is 0, output resistance is infinite. When we look into transconductance amplifier, we can see output signal is current, input is voltage. So I divided by V, it is transconductance. So how it's been constructed? Input side is Thevenin's, output side is Norton. So this is transconductance structure. So output current is proportional to input signal voltage. IL is equal to GM into VA. So we can see input resistance is very high, output resistance is also very high in this transconductance amplifier. Once when we look at trans resistance amplifier, it is the reverse. We can say output is voltage, input is current, so V by I is resistance. So it is called as trans resistance amplifier. So input side it is a Norton circuit, output side is a Thevenin circuit, and V naught equal to Rm into Ia. So input side is very less, output side is input impedance is very high, output impedance is 0. So it's been intimated as Ri is infinity, R naught. So this is a general feedback network which consists of basic amplifier circuit, sampling network, feedback network, and the mixer network. So once when we design a feedback amplifier, of three networks. What are the networks? Sampling, feedback, and mixer. So sampling is taken from the output. Feedback is part of the output. Mixer is combining both your input signal and the feedback signal. This is the concept. So while we are doing this, we have to understand how the sampling is. So when we consider sampling, it has been taken from the output. So the output can be of either voltage signal or current signal. We have to set whether it has to be connected in shunt or series. Remember this concept, output is sampled. So output has to be maintained constant. If voltage signal, which part it will be constant, when it will be constant, in parallel or series, only in parallel. So voltage sampling has to be done in parallel. Current sampling. So when the current will be constant, only when it is connected in series. So while doing sampling, when we are taking voltage signal, it should be connected in parallel. When we are taking current signal, it should be connected in series. That is for the right. So look into the circuit. Voltage sampling, we connected in parallel, right, across the output. Current sampling, you see, it has been taken in series across the output. So it is called as loop sampling or next feedback network. As you know, part of the signal has been connected to the circuit, that is the feedback circuit. The signal will be given to the mixer. Mixer again, two types of mixing. Either we can do series mixing or current mixing, shunt mixing. Again, it is based upon the signal at the input side, voltage or input. Mixer, you remember in this way, distribution. You are going to distribute the signal. While distributing, if it is an voltage signal, how it will be distributed? Series or shunt? Only in series, we can able to distribute the voltage. Current means in parallel, then only we can able to distribute the current. So distribution can be done in either in shunt depending upon our signal. So when it is of voltage signal, it should be done in series. Can you see it is a series mixer when it is a voltage signal. And in case if it is of current signal, then you can see the connection in parallel, shunt mixing. So this is the concept. So we have sampling network, feedback network, mixer network. Sampling network, voltage or current, either in series or shunt. Series mixing, shunt mixing, based upon the signal, current or voltage has to be decided. Once when you are thorough with this part, we can design feedback circuits. The next session will get in detail with respect to feedback circuits. Thank you.